Okay, another application of exponential and logarithmic functions. Here we're given an exponential function that describes a drug being eliminated from the body through urine. And it says that suppose that for a dosage of 10 milligrams, the amount T remaining, which would mean in milligrams, in the body T hours later is given by the formula A of T equals 10 times 0.9 to the power T, and that in order for the drug to be effective, at least 3 milligrams must be in the body for it to be working. Okay, now first I want you to make sure you understand your formula. You have an amount present at time 0 times a multiplier per hour. The multiplier is 0.9, which means that every hour you're retaining 90% of what you had the previous hour, which also means that every hour you're losing 10% of what you previously had. Now, if you wish to figure out in part A, when will 3 milligrams be left in the body, then 3 is in the place of A of T, and you're solving the equation 3 equals 10 times 0.9 to the T power. This is an exponential equation, and your best shot at solving it is to isolate the base 0.9 to the T power. So I'll divide both sides by 10. And while I could write that as 3/10 or 1/3, probably what I would not do is write 0.333. I would leave it unrounded, whichever way I approach this. And then we know the definition of the logarithm says that log base 0.9 of 3/10 is T. Okay, that would be perfect if we had the calc pad in this problem. When you see the little dots I've put under these boxes, there's no calc pad, so you have to do this in your calculator. So using the change of base model that I've shown you before, you can either start from scratch with change of base and do logarithm of each side, either log base 10 or log base e, or you can convert after the fact. I'll just convert after the fact to log base 10. So it'll be log base 10 of the value 3/10 divided by log base 10 of the value 0.9. And let's pause for a second and do our calculation. And in my calculator I get, with floating all 9 decimal places, I get 11.427717 and some change. So look at what it tells you to do as far as rounding your answer, and it says round your answer to 2 decimal places. So I'll write 11.43 hours. Okay. Now part B, that's what's the half-life of the drug. Well, half-life is the time it takes for half to disappear. The amount present is the amount present, not the amount that's disappearing, but in the sense of half-life, if 50% is gone, 50% remains, and we mean 50% of the original amount. And we'll have when will the amount be 50% of the original amount. So now notice if I write the equation out using the formula, what happens nicely here and consistently is it really doesn't matter what the initial amount is. The growth or decay position is determined by this repeated multiplier here. And we can solve the problem either doing the log of both sides, since you already know you want to round to do decimal places, or we can do what we did before, and I'm going to stay consistent here, that this would be log of 0.9, log base 0.9, excuse me, of 0.5 equals t. And if I do a change of base conversion, that would be log base 10 or e, take your pick, of 0.5 divided by log base 10 of 0.9. And let's do the count. And I get 6.57 88 and some change hours, which we are then asked to round to 2 decimal places. So I'll actually enter 6.58 hours is the half-life. Okay, now think about what half-life means for just a moment. Now we've solved the problem, but half-life means this. This is the time it takes for you to reach half of 10 milligrams. So that's the time it takes for you to reach 5 milligrams. So if it takes 6.58 hours for you to reach 5 milligrams, it certainly should take longer for you to graduate down to 3 milligrams. Particularly if at this stage we have 5 milligrams, that's half of the amount, then that would mean in 6.58 more hours, you're down to 2.5 milligrams. Because you're taking half of the half. Oops, excuse me, that's supposed to be milligrams. I hope this makes sense to you guys. So it's a way of me checking myself. Okay, so 3 milligrams, it's not as far down the graduation as 2.5, and 6.58 times 2 is roughly 13.2 hours total, and so our numbers actually make sense. So it should be somewhere around 11.43 hours that we reach 3 milligrams, because that'll be before we graduate down to 2.5. Okay, I hope this makes sense. All right, thank you.